Tonight we're trying to find 4 prime divisors of an impossible to calculate manually integer. Now one that we can find quite quickly is just to observe that this very first term has to be odd. 909 is certainly an odd number. If you raise it to any power, you get an odd number. And if you add 1 to any odd number, you get an even number. Okay, so that means 2 has to be one of these 4 divisors. Or it could be, however you might find them. But two could be one of them, right? Because 2 is the only even prime. So again, that's simple enough, but we're supposed to find 4, right? Okay, now let's move along. As usual, a lot of times you can use algebra to leverage things here. Now this result down here is it's a fun result because a lot of people will forget this, but it's kind of like the generalized version of the sum of 2 cubes. Okay, so you'll notice right here, if we take a to be equal to 909, okay, and b to be 1, we get a fairly simple expression. Okay, we'll take b to equal 1. Now notice what happens when we do that. We get this result right here. And this looks awful strange to write it this way, right? But it makes it fit this form, okay? So that's kind of a fun thing, to notice that you can actually use something like that, okay? And I think this is a fairly common algebraic identity in competition mathematics. But you can see right here, once we do this, okay, our A is 909 and our B is 1 in this algebraic result here, this algebraic identity, we get a very straightforward looking expression here. And this very first factor sums up to 910. Okay. Now, just a comment about this: if you don't trust this, if you don't trust this identity up here, it's kind of what they call telescoping, I guess. If you take a look right here, look at the 1 times the 908. Right, that's a positive 909 to the 908. But now, if you take 909 and multiply it by this, you get minus. See, this is 909 to the first power, right? So you see how those two things cancel out? This object right here, when you multiply, you get 909 raised to the 908th power. When you multiply this out, you get minus 909 to the 908th power, right? So that makes you trust the fact that you get kind of an alternating situation here where everything cancels out except the first and the last terms, which would be 909 to the 909 and then just 1, okay, which is what we're looking at, right? And so anyway, here we go. We got everything working in our favor right here. And all we have to do is just determine how many prime factors 910 has. Well, it's not too hard to determine that 910 certainly is divisible by 2. We've already seen that. Well, we know that. Yeah, we know that. But 910 is also divisible by 5. Now notice it's not divisible by 3 because the sum of the digits is not divisible by 3. 9 plus 1 is 10. That's not divisible by 3. So we know we have 2, we have 5. And also this is very favorable for us. We don't have to do anything too fancy because 7 times 13 is 91, right? So you can just write down 7 times 13 and you're done with the problem. Now sometimes you wouldn't get a number this easy where you could just see right off that it was 7 times 13. You'd have to use divisibility test. There's a divisibility test for 7. You take the last digit and multiply it by 2 and then subtract it from where it remains, but you would just get 91, and there's something kind of the same for 13. But there's no need to mess with any divisibility test for this particular special case since 7 times 13 is manifestly 91. Okay, so these are our 4 prime divisors, folks: 2, 5, 7, and 13. Now, again, there's going to be plenty of others, I'm sure, but I think it'd be very challenging to find any prime divisor of this piece right here. Okay, that would be a whole other problem. And again, we're not saying these are the only prime divisors, but we did follow the directions and we found these four. And you can make a lot more out of this problem than I've made it, but I just thought it's nice to show you this idea because, you know, two's easy from the word get-go, right? But then you have to use this result, which is not so common, say, in a college math class so much, really. It's more of a competition level identity. You might not see this too much, like, say, in a high school math class. Maybe you would. But to know that you can use this formula and rewrite this is just 1 raised to the 909. It's trivial after you see it, but then you realize it fits this identity, and then you get a favorable result when you actually use the identity just looking at the very first factor. Okay, that's all. The 4 factors are 2, 5, 7, and 13. Thanks for viewing.